Okay, so we are going to discuss May-June 2022 Pure Mathematics 3 paper, variant 3.3, okay, for this video. Okay, so let us start with question number 1. Okay, for question number 1, they give us this inequality and they want us to find in terms of A, the set of value for X that satisfy the inequality. And then please take note that A is a positive constant. All right, so for this question, generally to solve this inequality, the method that I'm using is I will square both sides. Right, so this is my our question. Okay, so when I try to square both sides, generally the modulus will become a whole bracket with a square. So 2 square is a 4, and then I'm having 3x plus a, and then I square it, smaller than 2x plus 3a, and also the whole bracket I square it. All right, so after I expand everything, for this inequality, I should get the quadratic form inequality. Okay, so I try to expand it first. All right, then multiply the 4 in. Okay, so eventually if I try to simplify and move all the terms to one side, I will have this quadratic inequality. Okay, and then to solve the quadratic inequality, generally what we do is that we try to factorize it and we try to find out the critical value for the x. All right, so for this kind of inequality, right, you can treat actually the a as a constant one if you want. Okay, so if you try to factorize it into two brackets, then you should have this. I'm having plus and then minus. Okay, so the critical value for x, you let the bracket x equal for x minus a equals to 0, and also you try to solve the other bracket. So you're having x equals to a over 4. This is one of the critical value, and also another one will be negative 5a over 8. Okay, so what are you going to do with these two critical value? Right, so you can try to use any method that you like to determine the answer or the range for the x for this inequality. Okay, so for me, usually I will use number line. Okay, so for these two number line, I will draw the number line based on the critical value that I have. So a over 4 should be on this side, and then negative 5a over 8 should be on left hand side. So please take note, in the question just now, they already mentioned that a is a positive value. All right, so a over 4 should be a positive value still, so it should be on the right. Then this one should be on the left. And then I try to draw the arrow. So for the bracket for x minus a, it is positive at this value when x is greater than a over 4. And then for the bracket 8x plus 5a, this whole bracket, this particular bracket is positive when the value of x is more than negative 5a over 8. So the line, okay, the area with the line actually denotes the positive sign. Without the line means negative. So I multiply positive with positive, that means bracket with bracket. So multiply positive with positive, you get a positive. Positive, negative, you get a negative. And then negative, negative, you get a positive. Right, and we are looking for the answer now. So for the answer, we are looking for overall smaller than 0, which is negative value. So in overall, the negative value will be here, where the range is given by negative 5a over 8 until a over 4 for the value of x. So this is how we solve the inequality, quadratic inequality. All right, so please take note that this is not the only method that you can use to find out the inequality, the range for x. You can still using the U-shape or N-shape graph if you want, or you can also use the table of sign if you want to get an answer. So, but basically the answer will be the same no matter what is the method that you are using. All right, so this is how we solve question number 1. All right, so question number 2. They want us to solve this equation with cos bracket theta minus 60 equals to 3 sine theta. Right, and then the theta is between 0 to 360. For this question, generally, we might need to expand this part, okay, cos theta minus 60 by using the compound angle formula first, where the formula is provided in the formula booklet. So if this is the formula booklet page, under the trigonometry part, the compound angle formula that we are going to use is this one. Okay, so we are trying to use this formula and expand the equation that we have on the right hand side. Okay, all right, so maybe we can start now. Right, so this is a formula that we have. Okay, so basically we are going to apply the formula where we are having cos A minus B. So we are following the sign at the bottom. All right. Okay, so I will have cos A cos B. So assume that this is the A and this is the B. Okay, so I'm having cos A cos B plus sine A sine B. And it is equals to 3 sine theta. Okay, so next step, for cos 60 and also the sine 60, generally they represent some values. So if you try to get the value for cos 60, you realize that it is actually half cos theta. And then for sine 60, if you try to figure out the value, it will be square root 3 over 2. And then I'm having sine theta equals to 3 sine theta. All right, so for this whole equation, generally you can see that we are having the term sine theta and also the cos theta. So to solve it, I think it will be good if we can rephrase it into another trigo where sine and cos, we can change it become tangent. All right, so I try to move this term over and factorize out the sine. If I factorize out the sine, I will have 3 minus square root 3 over 2. And then try to bring and simplify, okay, all the terms to one side, where all the number terms to one side, and then sine over cos, I'm having tangent theta to one side. Okay, so from here you can see that we are having actually tangent theta equals to this particular fraction. And of course, you can use the calculator to help you. Okay, so first you want to find out the basic angle first. So for the basic angle, if you try to press the calculator for tangent inverse, okay, for the fraction, okay, we will get a value which is 13.2 degree. Okay, then please take note that this whole fraction here is generally a positive value. It is a positive value. Okay, so to get an answer for tangent with a positive value, we can go through the quadrant. Okay, so which is a quadrant? Which is the answer from which quadrant that I need to accept for my solution? All right, so we're looking for tangent positive. So first quadrant, tangent is positive. Therefore, I want to answer from this quadrant. And the answer should be a basic angle. Therefore, the theta is actually the basic angle, which is 13.2. Okay, so in the second quadrant, only sine is positive. So we are not getting the answer for this part because we are looking for tangent positive, right? Okay, so for the third quadrant, tangent is positive also. So I want to accept this answer from third quadrant. So how to get the answer from third quadrant? Basically, it is 180 plus basic angle. So I will take 180 plus 13.2 and I will have 193.2. All right, then for the last quadrant, cos is positive, tangent is not positive. Therefore, I also don't want the answer for this fourth quadrant. Right, after I go through one quadrant, we realize that we have go through the quadrant from 0 until 360. Therefore, the final answer for theta should be these two only, where they are 13.2 and also 193.2. Question number 3. Show that this equation can be written as a quadratic equation in x. All right, so to write the equation involve the logarithmic function, okay, then change into the quadratic equation, right? Basically, we need to get rid of all the, we might need to get rid of all the log function first, okay? So let's start with the question here first. We are having log with base 3. Okay, so to get rid of the log base 3, right? Before I can cancel off the log base 3, basically I need to ensure that all the terms here are having the same base. Where 1, I also need to change it become a term with the log function with base 3 as well. So for 1, right, I can write as a 1, and I'm having log 3, 3. Then plus 2 log 3 x minus 1. Okay, so after I have all the term with the log function, okay, I will try to bring all the number in front back become the power. Therefore, I will have this 1. When I bring it back, it is still 1, right? So I'm having 3 power 1 here. And then plus log 3. This bracket, I'm having it with a square. Alright, so now I will want to combine the right hand side. There are 2 terms with the log. I want to combine them become 1. Where I will have log 3 and then 3 multiplied with x minus 1 squared. So from this step to this step, I'm using the concept or idea where log A plus log B can be written as log A multiplied with B. Alright, so this is what I'm applying here. And now until this step, right, we are having each side with 1 log base 3. So I can cancel off the log base 3 and left only the function with the x both sides. Okay, so to simplify it, I'll expand the x minus 1 square. Right, so this is what we have. And then if I continue further and rephrase everything, you should have 3x squared minus 8x plus 2 equals to 0. So you can see that we are getting this quadratic equation in x, right? Okay, so of course, this is not the only method. There's another method suggested where you can try to bring this log 3, okay, the term with log 3 over the left-hand side, and then you simplify it by bringing the base 3 to the other side also can. All right, so for me, I try to change all the terms with the same log, with the same base, right, which is log 3. Then only I can simplify it and cancel off the log 3 later. All right, so this is what you have for part A. And now let us proceed to part B. Okay, so for part B, they want us to solve this equation and then giving your answer correct to 2 decimal places. All right, so for this question, if I compare it with what we have in question number A, so this is the equation in part A, and this is the equation in part B. Okay, before I can solve the part B, I try to compare them, and I realize that generally 2x will become 4y, and then the x here will become 2y. That means if you try to compare these two equations together, right, basically you should know that from here, x is equals to 2y. All right, so they want us to get the value for y lah. All right, so before we can get the value for y, right, we can try to solve for the x first. Okay, so continue from part A. Just now from part A, we are having a quadratic equation 3x squared minus 8x plus 2 equals to 0. Okay, I try to get the value for x first, and then I realize I cannot factorize it. Therefore, I apply the quadratic equation formula, where I'm having negative b plus minus square root b squared minus 4ac, 4ac, right? And then divided by 2a. Okay, all right, so if I try to simplify everything, eventually I will have two answers here where x can be equals to 4 plus square root 10 divided by 3, and also x can be equals to 4 minus square root 10 divided by 3. Okay, so basically after I get the value of x, I can continue later to get the value for y. But before that, I want to double check all my answer here first. So x equals to 4 plus square root 10 over 3, right? this is a positive value. When I substitute it into my original equation, right, nothing wrong with it. So the equation is still correct. But for this particular answer, if you try to figure out this answer, generally it is a negative value. If I substitute this negative value into this part, no problem. But if I try to substitute into this part, I will have log, basically log negative value. So when you're having a log negative value, right, there's a max error. Okay, so that means for this particular answer, there's no solution. So we can ignore this. All right, so we should continue with this value only to get the value for y. Since we know that x equals to 2y, right? So 2y is equals to 4 plus square root 10 over 3. And therefore, the value of y, you need to take this value divided by 2, where correct to 3 significant figure, the answer should be 1.19. Oh, sorry, not 3 significant figure, it should be 2 decimal places requested by the question. All right. So this is what we have for 2 decimal places answer, where y equals to 1.19. Okay, so we come to question number 4. We have a curve equation, and then it is told that we are having 2 stationary points in this interval. Okay, so they want us to find out the dy dx and show that it can be written in this form. Okay, so let us start with our equation. Y equals to e power negative 4x tangent x. Okay, so first of all, you can treat this, okay, as a first function, and then this is another function. So you can see that it is actually the product of 2 functions. So to get the dy dx for the product of 2 functions, right, we have to apply the product rule. Okay, so how to get the product rule here? Basically, it's like this. Okay, so you copy the first bracket, you differentiate the second. So differentiate tangent x, you get secant square x. And after that, you do it the other way around, where you try to differentiate the first bracket. So differentiate the first bracket, you're having negative 4, then e, negative 4x. Copy the second bracket, which is tangent x. Okay, and then now we are trying to simplify our terms here, where we wish to have secant square x to be factorized out and also e, negative 4x to be factorized out. Okay, so first step, maybe I try to factorize out the e, negative 4x first, and I'm having secant square x minus 4. For this tangent, I can rewrite it becomes sine over cos. All right, and after that, for the second step, I try to factorize out the secant squared from the equation. If I factorize out the secant square x from the equation, so the first term here, I'm having a 1. And for this second term here, I need to have sine x multiplied with cos x. So that later when I simplify, when I multiply the secant square x inside this term, I will get back the 4 tangent x. All right, so you can imagine it in this way, where if you try to take out cos square from this term, okay, so if you want to take out the cos square from this term, generally the cos x will be taken out. All right, and then another cos x need to be taken out. Therefore, to balance it, you have to multiply a cos x on top. So this is how we get the answer. All right, okay, then I already factorized out the sine square and also the e power negative 4x. Now we try to change this one. Okay, this particular term sine 2x, because in our equation here, we don't have any sine 2x yet. Okay, so what we can do is we try to simplify this. 1 minus 4 sine x cos x, I will rewrite become 2 multiply with 2 sine x cos x. And then followed by e power negative 4x. And from here, by applying the double angle formula, I'm having 2 sine 2x and then e negative 4x. Okay, so what am I applying here is basically like this. We know that for the double angle formula for sine 2x, it can be written as 2 sine x cos x. So this is how we rephrase it and get the answer that they want us to show. Okay, so this is what we have for part A, question number 4. Right? And you can see that A is a 1 and also B is -2 for this particular answer. All right, then let us proceed to part B. Okay, so for part B, they want us to find the exact, highlight the word exact. Basically, your answer should be in sub form or pi form, right? X coordinates of the two stationary points. So we are looking for the X coordinate for two stationary points. Right, so to get a stationary point, we'll let dy dx equals to 0. Okay, so what is our dy dx just now? We already get it in part number 1, where our dy dx should be secant square x, and then 1 minus 2 sine 2x, e negative 4x, and it is equals to 0. All right, so if we try to solve this equation, basically they are having three parts of the brackets. So the first part is secant square x equals to 0. And then if you try to continue and try to solve it, right, you have cos square x equals to 1 over 0, where there's a math error occur here, and this is the part that we should ignore. Okay, then how about if we have a look for this e negative 4x? So e negative 4x equals to 0. If you rephrase it, you have 1 over e 4x equals to 0. And when you try to solve for e power 4x, right, you will get 1 over 0 as well. So there's also another math error occur here, and this part is something that we should ignore. All right, so the last part of the bracket is this one. So we are trying to solve this. So 1 minus 2 sine 2x, it is equals to 0. So from here, we are having sine 2x equals to 1 over 2. All right, so we are looking for the quadrant with sign positive. And then in the question itself, basically they are asking for the x from 0 until pi over 2. All right, so this is from 0 until pi over 2. You can have a look for question number 1 again, pi over 2, right? Okay, so now for us now, we are having 2x now. So to solve for the solution for 2x, right, we should actually look from 0 until pi. So that means you have to go through the first two quadrants for sine half, sine 2x equals to half. All right, so first of all, of course, you can get the basic angle first. Okay, so what's the basic angle? It is sine inverse 1 over 2. And we should have 60 degree, which is, we should have 30 degree, which is pi over 6. All right, so when we are having the pi over 6 here, now we're looking for the answer of 2x first. Okay, so to look for the answer of 2x, basically we need to go through the first two quadrants. Why we need to go through the first two quadrants? Only because it is stated that our 2x is between 0 until pi. So 0 until pi means the first two quadrants. Right, so let's have a look. First quadrant, is it sign positive? Yes. So to get the answer from the first quadrant, right, so we are straight away take the basic angle as answer. So the basic angle is pi over 6. So the first answer for 2x will be pi over 6. And we proceed to the second quadrant. So is in second quadrant, is it sign positive? Yes also, right? So to get the answer from the second quadrant, basically it is 180, which is the pi, minus the basic angle. So you take the pi minus pi over 6, and from there you have 5 pi over 6. Okay, so I'll stop here for the two quadrant because in the question it stated that 2x is from 0 until pi. Alright, so I can proceed with the final answer. To get the correct final answer, I have to divide all the answer that I get just now by 2. So I'm having pi over 12 and also 5 pi over 12. So we should stop here, and this is basically the exact x coordinate for the two stationary points. Okay, so we come to question number 5. We are having a complex number where u is equals to 3 minus 1, 3 minus I, and then they want us to show on an elegant diagram. Okay, there are 4 points here. We are having origin O, A, B, and C, where A is actually the point U, B is U conjugate, and C is U conjugate minus U. Okay, so before I can sketch the graph, basically I need to know, all right, since our U is 3 minus I, right? Okay, therefore the U star will be equals to 3 plus I, which is the conjugate of U. And then if I want to get the u conjugate minus u, I'm having 3 plus I minus 3 minus I. So if I try to simplify this, I will have 2I. Okay, so once I know all the coordinate, all right, for the points already, then I can start sketching it. Okay, so to sketch it, basically we can put it here. Okay, all right, so maybe you can just use a simple graph, okay, to show it in a clearer way. Okay, so this is my real axis and this is my imaginary axis. Okay, so we can try to label them. We are having 1, 2, and 3 here. And then we are having 1, 2, and 3. Okay, so I start plotting the graph. Okay, so origin means 0 and 0. Okay, so when having u is 3 minus I. So 3 minus I means that u should be here. This is actually the u, or I can plot it as a lah. Or maybe I should plot it as a, right? This is a, point A, but it is actually a complex number u. Okay, then after that we are having point B. So point B is u star, u conjugate. So it is 3 plus I. 3 plus I, basic, please should be something like this. At here, this is the B, or we write as u conjugate. And after that, for the next part or next point is u square, sorry, u star minus u conjugate minus u, which is 2I. So 2I should be on the imaginary axis. So for this is the point C, and it is actually u conjugate minus the u. So you're having the diagram, okay? So O, A, B, and C. So you can see very clearly. And then they want us to state the type of quadrilateral formed by point O, A, B, and C. So for this quadrilateral, if you try to join all the points together, right? Okay, basically you can see that the ratio changing of x and y, they are the same actually for this one. So they are having the parallel sides for CB and OA. Also, we are having the parallel side of OC and also AB. Therefore, for this particular quadrilateral, it should be a parallelogram. All right, so for this particular argon diagram, right, in exam, please try to sketch it properly by measuring the correct ratio for both the x and y axis so that you can see clearly what is the shape of this quadrilateral. All right, if not, if your ratio is out of the ratio, I mean the ratio that you're using for x and y axis is not accurate, then basically you won't see clearly what is the correct type of the quadrilateral that you are having here. All right, so for part A, this is what we have uh for the shape OABC. It is actually a parallelogram. Okay, right, then now let's continue to part B. So they want us to express u star over u in the form of x plus yi, where the x and y are real. Okay, so let's start with u conjugate divided by u. All right, so u conjugate is 3 plus I, like what we mentioned just now, and the u is actually 3 minus I. So this is a fraction with complex number at the denominator. We should try to rationalize it. So to rationalize it, basically we are multiplying the fraction, right? The fraction with the conjugate. So 3 minus I multiply with the conjugate as 3 plus I. So the same thing applies on the numerator so that they are still the same equation. And now I try to expand everything for the numerator and denominator. So for the denominator, if you didn't do any careless mistake and you try to simplify it, you have 9 plus 1. For the numerator, 3 times 3, you get a 9, then plus 3i plus 3i, then plus I squared, which is negative 1. All right, then from here, again, I continue simplify it, and eventually I will have this complex number, where 4 over 5 plus 3 over 5i. Okay, so this is how we express the formula u star over u in the form of x plus iy. All right. Okay, so 4 over 5 plus 3 over 5i. And now we proceed to the next part. So next part, they are asking us to considering the argument of u star over u, prove that we are having this equation. Okay, so first of all, from the answer that we get in part number B, we already simplify this term, become 4 over 5 plus 3 over 5i. Okay, so this particular complex number is in the first quadrant. To get the argument of this complex number u star over u, right? This is in first quadrant. Therefore, we are taking tangent inverse y, which is 3 over 5, divided by the x, which is 4 over 5. Okay, if you try to simplify this term, you are having tangent inverse 3 over 4, right? Okay, so besides, because we are having the fraction where u star divided by u, therefore, if I want to get the argument for u star divided by u, there's another method where I can take argument of u star minus the argument of u. How to get the argument of u star? Okay, so again, let me write out the equation again here. What do we have for a u star? So u star is 3 plus I. Where is the u? U is 3 minus I. Okay, so to get the argument for u star, it is in the first quadrant. Therefore, the answer should be tangent inverse y, which is the 1, divided by x, which is the 3, minus the argument of u. Okay, so for the argument of u, this is in the fourth quadrant. Okay, so for the argument of u, this is in the fourth quadrant. Let's say this is the u. So this part is a 1 and this is a 3. Okay, so to get the theta, it should be actually equals to negative tangent inverse 1 over 3. Why is it negative? Because we are measuring it in the opposite direction, in the clockwise direction. All right, therefore I should put a negative in front of the theta. And then if you look at the triangle here, so theta basically tangent theta is 1 over 3. Therefore you're having 1 over 3 here. Okay, so if I try to add these two together, I'm having 2 tangent inverse and then 1 over 3. So basically you can see that both answer here, this and this answer are actually the argument of u star over u. And this is how we show that the tangent inverse 3 over 4 is actually equals to 2 tangent inverse 1 over 3. All right, okay, so this is how we solve question number 4. Okay, so question number 6, we are having the parametric equations, and then this is the parametric equation. All right, and then the t is given from 0 until pi over 2. First, they want us to find out and show that dy dx is equal to cos t over sine square t. Okay, so we should start from our first parametric equation where x equals to 1 over cos t. So to me, this is a fraction, right? So to apply differentiation in a fraction, basically we can apply quotient rule. Okay, so for the quotient rule, we need to square the denominator, differentiate the bracket on the top, differentiate 1 and get a 0, copy the bracket at the bottom, then minus, now I copy the number on top, differentiate the bracket at the bottom. So differentiate cos t, I'm having negative sine t. So from here, I try to simplify it. I will have sine t over cos square t for my dx over dt. Okay, and then after that, the other equation will be y equals to ln tangent t. Right, so to apply the differentiation for y with respect to t, okay, so differentiate the ln and bringing down the bracket inside the ln become a denominator where I'm having 1 over tangent t, and now I need to differentiate the tangent t. So differentiate tangent, I get secant squared. Okay, and Because of our final answer, you can see that for the final answer, we are having the trigo, which is cos and sine. Therefore, it will be better if we can change this one. Our answer for dy over dt become everything in cos and sine. So 1 over tangent, it can be written as cos t over sine. And then for the secant square, I can rewrite become 1 over cos square. Therefore, if I further simplify it, I will have 1 over sine t, then multiply with cos t. Okay, so let's proceed to the next step. I want to find out dy dx. So to get the dy dx, basically we need to apply chain rule, right? So we are going to use dy over dt multiply dt over dx so that we can get back the dy over dx. Alright, so dy dt, we already get it from our answer just now, which is 1 over sine t cos t. Multiply with dt dx. We are having our answer dx dt like this. So dt dx means that you have to make this one upside down, and I'm having cos square t divided by sine t. Alright, so from here, if I try to simplify it, cos t and the cos square t can be simplified. And from here, you can see that our answer will be cos t over sine square t. Right, so this is what they want us to show for our dy dx. Okay, then let's proceed to question number 6, part B. Okay, so for question number 6, part B, they are asking for the equation of the tangent to the curve. Equation of the tangent to the curve when y equals to 0. Right, so to form the equation of tangent, right, we need the gradient of the tangent, and we also need a passing point. Alright, so first of all, we need to know what are all the values for the t and also the x when y equals to 0. Okay, so when y equals to 0, we get the equation of y just now, which is ln tangent t equals to 0. Therefore, the tangent t is equals to e power 0, which is a 1. And therefore, t is equals to tangent inverse 1. It is given that t is in the first quadrant, right, from 0 until pi over 2 just now. So the t now is pi over 4. Okay, so once I know that my t is equals to pi over 4, we can use this value to find out all the other coordinates and also the value that we need. So as an example, we also need to find out the x. What is the formula for the x just now? So just now we're having formula of x, which is 1 over cos t. And now we have to substitute t into my x equation. So cos pi over 4. When I'm having cos pi over 4, it is actually square root 2 over 2. And then if I'm having 2 over square root 2, if I further simplify it, I will get a square root 2. So I have the y coordinate now. I have the x coordinate. And now I need to know the gradient of tangent. So to get the gradient of tangent, basically we should have dy dx. In part 1, we already know that dy dx is equals to cos t divided by sine square t. Therefore, I want to substitute the value of t into the equation now. So t is pi over 4. And then I'm having sine pi over 4 and then square. Okay, so for cos pi over 4, the value that I get is square root 2 over 2. And then for sine pi over 4, the answer is also square root 2 over 2, and I have to square it. Okay, so when I try to simplify this fraction, I will get 2 over square root 2 as well. And further simplify, I will have a square root 2. And now I'm having all the information that I need to form the equation of the tangent. Alright, so basically you can see that this is actually the gradient of tangent. And we need the coordinate, right? So we are having the coordinate for the point where y equals to 0 and also x equals to square root 2. So we can start forming the equation of tangent now. Okay, so to get the equation of tangent, it will be y minus y1 equals to gradient m. So m bracket x minus x1, which is the coordinate of the x, simplify the equation. So basically you can see that this is the equation of tangent that we have, which is y equals to square root x minus 2. Okay, so question number 7. We want to express the fx in the partial fractions. Okay, so first of all, let's have a look for the degree of the numerator and denominator first. Okay, so for this one, the numerator degree will be equal to 2. And then for the denominator, this is 1 and 2, right? So total become a 3, right? So this is a degree 3. So since the degree of the numerator is smaller than the degree of the denominator, therefore this is actually the improper, sorry, it is the proper fraction. Alright, so when you're having the proper fraction, we can straight away expand it, become a partial fractions. Okay, so this is what we have here. And we can actually try to separate these rational functions into two parts, where I'm having a over x minus 2, and also another one will be bx plus c over 2x squared plus 3. So we are having the bx plus c on top. It is because of the denominator here, the degree is a 2. Therefore, the numerator should be 1 degree lower, which is start from x power 1. Alright. Okay, so I try to make all the denominator disappear by multiplying the whole equation here using the original denominator. So this is basically what I get. Okay, so now I want to slowly eliminate all the unwanted unknown to get all the value for a, b, and c. So first I will refer to this bracket x minus 2, and I try to make this bracket become a 0. So I will let x equals to 2 for this case. When x is equals to 2, okay, substitute the 2 into the whole equation here. 5 times 2 squared plus 8 times 2 minus 3. I will get a 33. Substitute the 2 into this equation. 2 multiplied with 2 squared plus 3, and I have 11. So I'm having 11a here. When I substitute the 2 inside this bracket, the whole thing, bx plus c, will become 0. So from here, I know that my value of a should be equals to 3. Next, I will let x equals to 0, where I will try to make the b disappear. Alright, so I will let x equals to 0. Substitute 0 into this part, and also this part. I will have negative 3. Substitute 0 into the part A, so I'm having 3a. So 3a means 3 times 3 is a 9. Because we already get a value for a just now, which is a 3, right? So 3 times 3 is a 9. Substitute 0 into the bx, the b disappear, and I'm having negative 2c. So from here, if I try to rephrase everything, the value for c that I get will be equals to 6. Alright, so since I already have the value for a and c, to get the value for b, I can use any value for x, which I never used before. So for this case, I'm letting x equals to 1. Substitute 1 here, so 5 times 1 plus 8 times 1 minus 3. So for this case, I'm having 10. Equals to, substitute 1 here, so 1 times 2 is a 2 plus 3 is a 5. 5 times a is 3 just now, right, which is 15. Substitute x equals to 1 here, you're having a b, and then plus c, which is a plus 6, then negative 1. If I try to simplify this equation, then I will get a value for b, which is negative 1. So now I can see I already get all the unknown a, b, and c already. Therefore, I can rewrite my rational function into the proper partial fractions. Okay, so this is what I should have. Okay, so it should be equals to 3 divided by x minus 2, then 6 minus x divided by 2x squared plus 3. Right, so this is a partial fraction that I get for part number 8. Okay, and now let us proceed to part B. Okay, so for part B, they want us to obtain the expansion of fx in ascending power of x up to and including the term in x squared. Alright, so we will start from what we have, okay, of our partial fraction just now. So our partial fraction is 3 over x minus 2 plus 6 minus x divided by 2x squared plus 3. Okay, so first of all, what we want to do is like we try to rephrase it into the bracket with a power. So I'm having negative 2 plus x power negative 1. For this one, the 6 minus x I remain as a bracket on top, and then the bracket at the bottom I bring it up, become 3 plus 2x squared power negative 1 as well. Okay, so to apply the binomial theorem or binomial expansion formula, we have to ensure that the first term in the bracket is a 1. So I will take out a negative 2 together with the power, and my answer inside the bracket will become 1 minus x over 2 power negative 1. The same thing happened for this second bracket. So 6 minus x, I don't need to do anything because it is power 1. So I don't need to expand it or do nothing. We actually do nothing. So I just keep it like this. And for this second bracket, to apply the binomial expansion formula, I have to take out the 3 with the power negative 1. And then I factorize out the 3. So my terms now will become something like this. Okay, so simplify this term. I'm having negative 3 over 2, and I wish to expand the bracket 1 minus x over 2 power negative 1. For this part, if I try to simplify it, I'm having 1 over 3 multiplied with 6 minus x, and then multiply with 1 plus 2x power 2 divided by 3. And now I start to apply the binomial expansion formula. Okay, so for this particular bracket, the first term is 1. Second term is always n multiplied with the x. So n is the power negative 1. X is the term at the back, which is negative x over 2. So this is nx. The third term will be n minus 1 divided by 2 factorial. And then I'm having x squared. So for this question, I will stop here because if I try to simplify this term, I will have x power 2, where they want us to include up to x power 2 only. Alright, so for x power 3 and so on, we will actually ignore it. So this is what we have for the first part. And now for the second part here, plus 1 over 3, I just copy, 6 minus x, I also just copy it. Okay, so for this particular bracket, I'm taking first term, which is a 1. The second term is n times x. N is negative 1, x is this whole thing, right? So I'm having negative 1 multiplied with 2x squared over 3. And I will stop here also because if I realize that if let's say I continue to expand it, right, I will have x power 4 later, where it is not needed for this question. Right, so for your reference, this bracket, after I expand it, I'm having this. And then for this particular bracket, when I try to expand it, eventually it is this one. Okay, and now what I need to do is like we try to simplify everything and rephrase it into the simplified answer. Okay, so for these 3 terms in the bracket, after I simplify, I'm having 1 plus x over 2 and then plus x squared over 4 for this yellow color bracket. And then for the green color one, if I try to simplify it, then I will have 1 minus 2x squared, 2 over 3x squared. Okay, so next one, I try to multiply in the constant into the expansion here. Eventually, I'm having negative 3 over 2 minus 3 over 4x minus 3 over 8x squared. And for this part, if I try to expand it and also multiply the 1 over 3 into the constant, into the bracket, I'm having 2 minus 4 over 3 x squared minus 1 over 3 x. So for your information, right, when you try to expand these two brackets, we are having some term which is the x power 3, and I will just ignore it. I didn't write it out here because I know that for our answer, we only interested for the term up to x power 2. Okay, so just for your reference, this part basically is simplified to this. And then for this part, if you try to expand it very slowly, eventually you will get this extension. Right? And now we want to do the last step to simplify the answer. So if I simplify without any careless mistake, my final answer should be 1 over 2 minus 13 over 12x and minus 41 over 24x squared. So basically, this is what we have for the binomial expansion for this question number 7. Okay, so question number 8. At time t days, so the t is measured in days. After the start observation, the number of insects in population is n. So the variation in the number of insects is modeled by a differential equation in this form. And then k is a constant and n is a continuous variable. It is given that when t equals to 0, n equals to 100. Alright, so they want us to solve this differential equation, obtaining a relation between n, k, and t. Alright, so for this question, before we can solve the differential equation, the very first step we need to do is we have to separate the variable n and also the variable t to each side. Okay, so for me, I will move the n to the left. So when I move the n to the left, right, I'm having n power negative 3 over 2 with the n. And I keep the k and also the cos on the right hand side. And you can see that now I'm having clearly all the variable n on the left and also all the variable t on the right. So after I separate the variable clearly already, then we can start the integration. Right, so for the integration n power negative 3 over 2, this is a basic integration where you add the power and divided by the new power. K is a constant, therefore I just copy. Integrate cos, I will get sine 0.02t and then divided by the differentiation of the 0.02t. I'm having 0.02 and then plus c. Okay, so to make this whole equation better, I'm trying to rephrase it. So simplify this, 1 over negative 1 over 2, I'm getting negative 2. Then divided by square root of n. I will take 1 divided by 0.02. When I take 1 divided by 0.02, I will get a 50. So my equation for now will look something like this, which is 50k and then sine 0.02t plus c. Okay, and before we can reach to the final answer, right, we have to find out the c first. Okay, so it is given that when t equals to 0, n is equals to 100. Substitute t equals to 0 and also n equals to 100. I'm having negative 2 over 10. Substitute t into the sign 0.02t, you will get a 0 here. So very obvious your c is equals to negative 2 over 10. Or you can rewrite it becomes c equals to negative 1 over 5. Alright, therefore, to write out the correct final answer one more time, my final answer should look something like this. Negative 2 over square root n equals to 50k, then sine 0.02t minus 1 over 5. Okay, so for this question, you can stop here because my answer now is having a variable n, constant k, and also the variable t. Alright, so this is actually an equation that show us the relation between n, k, and t. Alright, so this is what we have for part A. And now let's continue to part number B. Okay, so for part B, they are saying that when n is equals to 625, right, t equals to 50, they want us to find the value of k. Alright, so for now, we try to substitute all this value into our answer just now, which is this one. Okay, alright, so let us start. Okay, so maybe I can just try to copy the equation again. I'm having this as my answer in part A. Okay, so now I want to substitute n equals to 625 and also t equals to 50 into the equation. All right, so when I have 625 square root, I'll get 25 here. So I'm having 2 over 25 equals to 50k and then sine 0.02t. 50 multiplied with 0.02, I will get a 1. Okay, then minus 1 over 5. To get the k, basically what I need to do is like, I need to bring all the terms over divided by sine 1. Okay, so please take note that because of we have this sine 1 here, the 1 is actually measured in the unit of radian. So for the to ease the calculation of the process of calculation, your calculator can set it to the radian mode. All right. Then after that, you bring over the 50 and try to get the value of k. You'll get a very long value for the k, but basically, if I cut it short into 3 significant figures, then the answer will be equals to 0.00285. So this is how we obtain the value of k by just substituting the answer into our equation. All right. Okay. Then now let's proceed to part C. Now they want us to have the expression for n in terms of t and find the greatest value of n predicted by this model. Okay, so we need to rephrase our equation, become n in terms of t first. Okay, so again, I try to rewrite our answer in part A. So 50, k is 0.000285, right? But of course, when I we write it shorter. When for the calculation, I will just use the original value for the k, which is a long one, right? Then I'm having sine 0.02t minus 1 over 5. Okay, so first of all, I doesn't like to have this 5 here. Therefore, I need to multiply the whole equation with a 5. So I'm having 250 multiplied with 0.000285. Then sine 0.02t minus 1. Okay, and after that, if I try to simplify 250 with this term, then I'm having 0.07125 sine 0.02t minus 1. Okay, and next, because I want to make the n as the main object, right? So I want to change this side become positive first. I'm having this. And then bring up the n. Square both sides. Okay, so basically this is what we have for our equation n in terms of t. Alright, then after that, we want to find the greatest value of n predicted by this model. Okay, to get the greatest value of n, basically we need to focus on this term where I'm having sine 0.02t. Okay, to get the greatest value of n, this denominator must be as small as possible. Alright, so to get the denominator as small as possible, I will realize that I need to let sine 0.02t equals to 1. Okay, why I need to let it become 1? It is because of when I'm having 1 minus the value here, and this is the value which is the smallest for the denominator. If I let it become negative 1, right? So you are seeing that negative multiplied with negative 1 become positive. So this is the denominator is not the smallest value yet. Alright, so to make sure that the denominator is the smallest value, I have to make sure that the sign 0.02t is a 1, which is the largest value, so that when I put it under the denominator, it becomes the smallest value for the denominator in general. Alright, so to get the greatest value of n, I will let sine 0.02t equals to 1. So when I simplify, I'm having 1 minus 0.07125 and then square. Okay, and eventually the value of n that I get is a long series of value, which is 1214.362602, and of course I will definitely change it become 3 significant figure, where for my answer I'm having 1210. Alright, so please take note that basically to get this answer right, the value of k that I'm using in my calculation throughout my calculation is actually the original long value for the k. Alright, so if let's say you didn't use the original long value, but you just use some shorter answer, okay, to get the in the value for k, to get the value for n, right? Your answer might not be what I show here. Okay, but no matter how, for marking scheme, right? So for marking scheme, they actually accept quite a wide range. So they accept the answer from 1209 to 1215. So as long as your answer is between 1209 to 1215, basically your answer is correct. Okay, so this is due to the reason that some of us might not use the long original value for the k, so we might cut it short. Therefore, it come up with slightly different answer here. Okay, so this is how we solve question number 8. Okay, so question number 9. Alright, so they give us the point A, which is having the position vector 1, 5, and 6. And then there's a line L, okay, with this vector equation. Okay, so they want us to find out find in degrees the acute angle between the direction of OA and also the L. Okay, so the direction of OA will be 1, 5, 6. And also the direction for the vector equation will be this one, -1, 2, and also the 3. So to find the acute angle between these two directions, basically we have to apply the dot product rule, right? So I'm having 1, 5, 6 dot product with the direction of the line, which is -1, 2, and 3. It is equals to the modulus of the first direction, 1 square, 5 square, 6 square, and also the modulus of the second direction, where I'm having -1 square plus 2 square plus 3 square, and cos theta. So this is basically what we apply. Okay, then now to get the cos theta, I apply the dot product here. So -1 times 1. 1 times -1, I get -1. 5 times 2, I get a 10. 6 times 3, I get 18. So simplify the modulus, I'm having square root 62 multiply with square root 14. Alright, so to get the cos, to get the theta, right, I have to bring over the cos, which is cos inverse 0.916439715. And the theta that I get will be equals to 23.6 degrees. Okay, so this is how we solve part 1 for question number 9. Okay, so let's proceed to part number B. Okay, so for part number B, they want us to find the position vector of the foot of perpendicular from A to L. Alright, so if I try to visualize this whole question, right, generally I'm having the line L here, and then this is my point A, let's say. So the foot of perpendicular will be this particular point here. And maybe for me, I will just label it as a point F. Okay, alright, so you will see that point F lies on the line. Basically, the pattern of the equation for the point F, right, the position vector for point F will be generally the line equation, the vector equation of the line. So the vector equation of the line, you already get it just now, right, which is 4 minus lambda, and then 2 lambda, and also 1 plus 3 lambda. So this is the position vector for the F, okay, because it is on lies on the line. Therefore, the equation of OF will be equals to the equation of the vector equation of the line. Okay, so some students might prefer to change the lambda become t lah, because it is assumed like there's a certain value of t. When I substitute into this equation, then we'll get the point F. Right, so for me it doesn't matter, right? So I'm just keeping it as lambda. All right, so now I know that I want to find the length. Okay, if let's say I want to find the length for AF, or I want to find the direction for AF, so I try to find out first, because I know that later when I have the direction of AF and I multiply them, I dot product with the direction of the line, it is equal to 0 because they are perpendicular to each other. Okay, all right, so we try to find out the AF first. AF means AO plus OF. So just now in part number A, we already know that the A is -1. A is 156, right? So AO means -1, -5, and also -6. Plus OF. So OF is what we have here, 4 minus lambda, 2 lambda, and also 1 plus 3 lambda. Okay, so I simplify this whole term here, this whole part here. Eventually, I'm having 3 minus lambda, -5 plus 2 lambda, and also -5 plus 3 lambda. This is what we have for AF. Okay, so to further continue with the calculation, right, I know that if I take AF, multiply or dot product with the direction of the line, it will be equals to 0 because they are perpendicular to each other. So from here, I'm taking AF dot the direction of the line. So the direction of the line basically is -1, 2, and also 3. Where you can take it from here, -1, 2, and also 3. And they are equals to 0. Okay, so dot product for these two direction of vector, this is what I get. And further simplify it, okay, so from here I will have 14 lambda equals to 28, where my lambda is equals to 2. Okay, so for this question, they are asking for the position vector of the foot of perpendicular, which is the OF, right? Okay, so to get the vector equation, the position vector for OF, I need to substitute the 2 into our OF equation. So when I'm having 4 minus 2, I get a 2. 2 times 2, I get a 4. And then 1 plus 3 times 2, I get a 7. Therefore, OF, the position vector for OF, the position vector for F will be 2, 4, 7, or you can write become 2i plus 4j plus 7k. Okay, so this is how we get a position vector for the foot of perpendicular for the A to line F. Okay, then now let's proceed to part C. Okay, so for part C, now they want us to find the position vector of the reflection of A in L. Okay, so again, maybe we can draw the diagram again to visualize it clearly lah. So I'm having a point A here, and then just now we try to find the coordinate, okay, for the foot of perpendicular, right, from A to the line. Okay, so for point A, if I want to write out in the coordinate form for the coordinate, so I'm having 156, right? 156 in vector. Therefore, when I write it out, it should be 1, 5, and 6 in the coordinate form. For the foot of perpendicular, just now we get 2i plus 4j plus 7k. So if I write in the coordinate form, it will be 2, 4, and 7. Okay, so for this particular question, they actually want us to find out the position vector for the reflection of A in L. So we are assuming that the line L is like a mirror. They actually want us to find out the position vector for this particular point. Let's say I put it as A prime. All right, so you should know that these two are the same distance. So I want to know what is this particular coordinate or the vector or the position vector. Right, so to make the calculation easier, basically I'm going to use the concept of midpoint in coordinate geometry. Basically, you know that F is actually the center or the midpoint of the point A and also its reflection on the line L, which means that if I try to find out the midpoint for A and also A prime, it is equals to F. So I'm having 1 plus X divided by 2, 5 plus Y divided by 2, and also 6 plus Z divided by 2. The answer that I get for this coordinate, the midpoint, right, will be equals to the point F, which is 2, 4, and 7. Right, so I think very obvious that we can straight away compare the x coordinate with the x coordinate. So you have x equals to 3 in this case. Y coordinate, you compare it with the y coordinate also, which is equals to 4. And from here, I get also the y equals to 3. Then the z coordinate, compare with z coordinate. So the value of z that I get here will be equals to 8. Therefore, the position vector for the reflection of point A on the line L is equals to 3i plus 3j plus 8k, where I feel that by using the concept of midpoint in the coordinate geometry will be the easier method to get this answer. Alright, so this is how we solve question number 9. Okay, so we are at the very last question, question number 10. We are having the constant A is such that this is what we have here, A, and then they want us to show that A can be written into this formula or this equation. Okay, so we should start from the integration basically. Right, so before you start the integration, right, so you can see that this integration basically built up from the product of two different functions. We are having x squared and also ln x. Okay, so x squared is algebra, which is the A. Ln x is ln, right, which is the L. So according to the rules that we have on LIATE, okay, when we have the product integration of the product rules, right, of the product function, right, product of functions, basically we have to apply the integration by part. So for integration by part, if we use the Layer's rule, the higher group will be equals to the u, and the lower group will be equals to the integration of dv. All right, so from here, let us start to form and set up the question first. So I will let u equals to ln x because ln x is at the higher group. And then when I'm having the integration of dv, it should be equals to integrate x squared dx. All right. Okay, so let u equals to ln x, and my du over dx will be equals to 1 over x. Then for the v part, this is actually the 1. So integrate 1 dv, I'm having the v here, and then x power 3 divided by 3. Okay, all right, so this is what we have. And now we have to apply the integration by part rules. Okay, so what's the rule for integration by part, or what's the formula for integration by part? Basically, if we want to integrate u dv, it is equals to uv minus v du. So we are going to apply this formula in our calculation here. All right. Okay, so let us start with the question. So I'm having 1a x squared ln x dx equals to 4. So to apply this formula, I'm having uv minus v du. So what is uv? So u is ln x, v is x power 3 over 3. So I'm writing it like this, x power 3 over 3 ln x, and I have to substitute the limit a 1. then minus the integration of 1a v du. So my v is x power 3 over 3, and then the du here is equals to 1 over x dx. And this whole thing will be equals to 4. Okay, and then now I try to substitute in all the value here. Substitute a into the equation. Here I'm having 1 over 3 a power 3 ln a. Substitute 1 into the equation. I'm having the whole thing 0. Okay, because ln 1 is equals to 0, so I didn't write out. Minus, take out the 3 here. And now I want to integrate x power 2. Okay, so let us continue from the integration again. Okay, so I take 1 over 3 and then integrate x power 2. I'm having x power 3 divided by 3, and then a and 1, which is equals to 4. Alright, then continue further. What do I have here is 1 over 9, and then a power 3. Substitute the a into the equation, substitute the 1 into the equation also. I'm having a 1 and equals to 4. Okay, so now I need to slowly rephrase my answer here into the equation that they want us to show. So first of all, I try to multiply in the 1 over 9, and then it is equals to 4. And after that, I don't want to have all the denominator here. Therefore, I multiply the whole equation with a 9. So eventually, I'm having 3a power 3 ln a minus a power 3 plus 1 equals to 36. Okay, so continue. Alright, so I'm trying to take out the a power 3. Then I left 3 ln a minus 1 in my equation. Then the particular number 1 here, I'll move it over, become 36 minus 1, which is 35. So I'm getting one step closer because I can see that 35 appeared in the final answer as well, right? Okay, so to get the a power 3, I will have 35 divided by 3 ln a minus 1, and take the cube root, okay, for both sides to make the power 3 disappear. And therefore, when I take the cube root both sides, I will have power 1 over 3. And this is exactly the answer that they want us to show. Right? So a can be written into this equation. Okay, so now let's continue to question number 10 part B. Okay, so for question number 10 part B, they want us to verify by calculation that a lies between these two numbers. So again, what is the equation for a that we have just now? So this is the equation. We're having 35, then divided by 3 ln a minus 1, and power 1 over 3. Okay, so to verify by using the calculation that a lies between these two values, right, we have to let this equation become a function. So I'm having fa equals to 35 and then 3 ln a minus 1 power 1 over 3 minus the a. That means I bring in the a to the other side, become minus a. And now I try to substitute 2.4 into the function. Okay, so I'm having 3 ln 2.4 minus 1 power 1 over 3 minus 2.4. Okay, so by the help of using the calculator, if you try to substitute the value inside, I'm having 0.382 for this particular f2.4. And then if I substitute 2.8, again, substitute the value 2.8 into the a. Okay, so which is 1 over 3 minus 2.8, and it is equals to a negative value. If you press calculator correctly, then you should get negative 0.241. Okay, so we can see the sign change appear here between f2.4 and also f2.8. So we can make the conclusion that the a lies between these two values. All right. Okay, so this is how we make the conclusion, because we can see the sign change. Sign change can be seen. Okay, so can be seen between the f 2.4 and also f2.8. Alright, therefore we can make a conclusion that the A lies between 2.4 and 2.8. Alright, so basically this is how we verify it by looking for the sign change between these two values. Right, okay, then now let's proceed to part number 3, part C. Okay, so for part C, they want us to use the iteration formula based on the equation in part A to determine A correct to 2 decimal places and also give the result of each iteration to 4 decimal places. So again, I'm writing out the iteration formula where this is what we have here. So this is our 1/3, right? Okay, so this is our iteration formula basically. And then we have to find out the root correct to 2 decimal places and each iteration to 4 decimal places. Okay, they didn't give us any initial value. Therefore, the initial value you can decide or determine from the part B just now. You can start from 2.4, you can start from 2.8, or you can start from any value between 2.4 to 2.8. Usually, I will use that as a guideline or a reference point to start. Okay, so for my answer here, okay, for my solution here, I try to put the initial value starting from 2.4. Okay, so to get the next iteration, I need to substitute the 2.4 into my iteration formula. So the iteration formula is the particular expression on the right hand side. That means I have to substitute A into the cube root of 35 and then 3 ln A minus 1. So how can I get this value? Right, so the A here, I actually need to substitute by using the 2.4, then minus 1. Okay, we can use the calculator to help us where we try to key in the formula. So the iteration formula is the cube root. The cube root, right? So shift this one. Okay, the cube root of 35. So 35. Okay, then the denominator is actually 3. Then ln A. So for A, right, we just put it as an X here. And then minus 1. Okay, so I try to key in the iteration formula, okay, into my calculation first. And then now I want to know if I substitute 2.4, right, what's the value that I get here? So I press calculate first. They're asking what's the value of X I want to substitute. So we will key in 2.4 and you press equal sign. So you can see that for the first value that we get is 2.7815. So 2.7815. And now to get the next iteration, I will key in 2.7815 here. Due to the reason that in our question, they're asking us to have the result for 4 decimal places, right, for each iteration. Therefore, you can see that I write out my answer in 4 iterations. When I key in the value also, I try to key in into 4 decimal places. So that means the next one will be, I also click on the calculate and they ask us again, what's the value of X that you want to key in. So I will key in this value now, 2.7815. So 2.7815. And I press the equal sign. So from here, my next iteration will be 5671. So 2.5671. Okay, so basically I will continue and repeat this process until I get the repeated answer for 2 decimal places. So 2.5671 for the next iteration, press equal sign. So from here you can see 2.6751. So when I write out 2.6751. Okay, so continue further. Okay, so calculate again. Then 2.6751, press equal sign, 2.6174. So 2.6174. Okay, so I shouldn't stop here yet because if I try to double check all the 2 decimal place answer, right, they are not repeated yet. for the 2 decimal places answer. So I should continue until I get a repeated answer lah for 2 decimal places. Okay, so for A number 6, I press calculate, then 2.6174 equal sign. So 6473. Okay, so again 6473. Haven't repeated yet, so just continue again. So A7. Alright, so A7, I need to key in 2.6437 equal sign, and I get 6334. Alright, okay, so maybe you try again, so calculate again. So 2.6437. Sorry, I think we get 6473 just now, right? Let me repeat again. Okay, so I think I already missed out all the things here. Let me try again. Okay, should be 3 degree, and then calculate. Okay, then let me have a look at 35. I want to have 35 divided by, okay, 3 ln x minus 1, then close bracket. Okay, so if I press calculate, okay, something wrong with the calculation. Right, so maybe I'm not able to show you lah. Maybe you have to use your own calculator and try to solve it for the next one. Okay, so if I didn't do any careless mistake, right, I realized that this particular value should be actually 6473, not 37. Okay, so key in 6473 into the equation, then I will get 2.6315 for A7. Then I repeat the same thing again. So insert 2.6315 into the equation again, into the iteration formula, I will get 2.6398. Continue again because I haven't get any 2 decimal places answer which is repeated, right? So if I key in for the next one, I will have 6354. Okay, so if I try to double check, this particular answer for 2 decimal places will be 2.64. This one will be also 2.64. Okay, which means that they are already repeated. You can stop here if you want. But usually for me, I will continue with another extra iteration further so that I want to confirm that this is the correct final answer. So now I key in 2.6354 into the iteration formula, and I should get 2.6377. Where if I double check the answer again into the 2 decimal places, right, it is still 2.64. So once I get 3 times repeated, for me, I will look for 3 times repeated. Then I know that the root or the value of A, okay, or the value of A is actually equals to 2.64. Right, so this is how we use the iteration formula and also the iteration method to get the value for the A here. Alright, so we ended our 10 questions for this particular paper. So thank you very much for watching this video.